How to solve quadratic equations, starring
Lily, the fabulous D. Jigger.
Mallory, Tomato Downey.
Thomas Adams,
Lily Monk.
And Alex Arnett. And the equation x squared plus 4x minus 1.
Step 1, axis of symmetry. First, before you do anything, you have to find the A, B, and C. And so the A is x squared. And since it's just an x, it would just be 1. And so B is 4x. And so you would remove the x and just put 4. And C is negative 1 because there is a subtraction sign right there. So it would be negative 1. And so you put it in your formula. So it would be negative 4 over 2 times 1. That would equal negative 4 over 2, which would equal negative 2. And so that would be your axis of symmetry.
On to step 2, the vertex.
Okay, so for vertex, thanks to Mallory for doing the axis of symmetry over here. For vertex, all you have to do is substitute negative 2 for all the variables in the original equation. So that would leave us with negative 2 squared plus 4 parentheses 2, negative 2, and minus 1. And then you just do some simple solving. The square up here, that would make negative times a negative positive, positive 4, plus 4 times negative 2, negative 8. Or you could just put minus 8, whichever you really prefer. And then minus 1. Just sort of break it down a little bit. You got negative 4 minus 1. And then that leaves you with negative 5. And then what you have to do now, for later, you have to put negative 2 and negative 5 together in parentheses, negative 2 dash negative 5. Okay.
On to step 3, the y-intercept.
So all you need to do to find your y-intercept is substitute 0 for all your x's. So you would get 0 squared plus 4 times 0 minus 1. So then you would get 0 plus 0 minus 1, and that your y-intercept would equal negative 1.
On to step 4, the
Okay.
symmetrical point.
So your symmetrical point is basically your y-intercept, but on the other side of the axis of symmetry, which is easiest to show when you have the graph in front of you, so we will do that later.
Okay. On to step 5, finding the x-intercept.
Okay, so the x-intercept, you have to use the quadratic formula, and so you basically substitute the a, b, and c in for the variables in the quadratic formula. So it would be negative 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 1. And this will all be over 2 times 1. So as you solve that out, you will get 16 minus, or actually no, it would be plus 4. And that'll all be over 2. So then, as you keep solving, you get negative 4 plus or minus 20 over 2. Okay, now you'll get negative 4 plus or minus 4.47, and that's the square root of 20 divided by 2. Okay, so negative 4 plus 4.47 would equal, okay,
would equal 0.47 over 2. And this would end up equaling 0.24. Okay? So now we're going to do the negative side of that. So this would be negative 4 minus 4.47 over 2. And this, you would get negative 8.47 over 2. And this would end up equaling negative 4.24. So then you'd have to put this in a bracket. So this would be negative 4.24 and 0.24.
Now on to the graphing. So first you have to graph your axis of symmetry. And that actually isn't a real point. So you just want to make an imaginary line, and that basically is your guideline for the rest of the graph. So the vertex has to be on the axis of symmetry. So our vertex just happens to be, if you remember, negative 2, negative 5. Our y-intercept is where it crosses the y-intercept, so that would be 0, negative 1. Now, as Lily said, the reflective point is a lot easier to graph on the actual graph. So what you have to do is see how many times it takes to hit the axis of symmetry, and then do that again to find the symmetrical point. Then to find the x-intercepts. Those are actually the solutions to your parabola. Not all parabolas, though, have them, but this one actually does. So 0.24 is 1, and it has to be on the x-axis, since that's where it crosses the x-intercept. And negative 4.24 is right there. So now what you have to do is connect to your parabola. I did it better than Miss Robinson. And then now you have to find the domain and range, which is also easier to do on the graph. So the domain is where it crosses the x-axis. So this can be anywhere along the x-axis. And since it's anywhere on the x-axis, which also includes crossing the y-axis, it can be positive infinity to negative infinity in parentheses. So that's your domain. The range is anywhere it can cross the y-axis inside the parabola. So that can be anywhere still inside the reach of the parabola. Now that can't go any lower than the y value of the vertex, and that would be negative 5. So if you put in brackets negative 5, and it can go up to infinity, so that's positive infinity, parentheses, and that is the domain and range. So labeling all the points. So the x-intercepts, which are the solutions to your problem, are simply there and there. The y-intercept is where it crosses the y-axis, so that is the y-intercept. The axis of symmetry is this imaginary line that spans through the problem. The vertex is all the way down here. That is the very center of the parabola. And then the reflective point, or the symmetrical point, is right there. And then the domain and range is, so the domain is all this space on the problem, and the range is all the space inside the parabola. So this is all domain, and this is all range.